Hello and welcome to episode 20 from the mathonlinetuition.com videos, where we're going through the C2 book. We're on chapter 4, coordinate geometry in the XY plane. So we discussed the XY plane before when we were talking about curves, but now we're going to see things in a more geometrical perspective. So 4.1, you can find the midpoint of the line joining y1, x2, y2 by using the formula as follows. So remember we mentioned before that we have a line as part of the graph, and we have x2, y2, and we have x1, y1, and obviously we mentioned in our previous video all the points. So we said that this is x2, this is x1, this is y1, and this is y2. We said this is y2 and this is y1, and this is x1, and this is the distance of x2. Well, it only makes sense that to find the distance between these two lines, we would take the distance between x1 and x2, okay, by adding them together and dividing it by 2. This is just very rough estimation, just by observation, just by visually inspecting the line, that this would be y1 plus y2 over 2, x2 plus x1 over 2, and the formula naturally would be x2 over 2, y1 plus y2 over 2. Okay, simple, straightforward, and you have a more accurate drawing here. So here are the coordinates, and you can plug them in and you'll figure it out. Example 2, the line AB is a diameter of a circle. Diameter is essentially one point from one side of the circle to the other side, which is shown or demonstrated by a straight line, or it's the radius multiplied by 2, where A and B are these points respectively. Show that the coordinates of the center, find the coordinates of the center of the circle. Again, you can see it's going to be the midpoint, because the midpoint of the diameter of the circle is the center. Okay, so that's straightforward, just something for you to know. And then again, you have the line PQ is the diameter of a circle, center 2 minus 2, given the point P here 8 and minus 5. Find the coordinates of Q. So again, you just have the two unknowns, which is x and the y, but you have everything else. So again, all you need to do is rearrange. So you have this one corresponding to x, where it's 2, and this one corresponding to y, which is the center is minus 2. Very simple, straightforward, no problems there. Example 4, the line AB is the diameter of the circle center C, where A and B are, and then you have the points. The line L passes through C and is perpendicular to AB. Find the equation of L. So what you need to do at this point here is the following. You know that you have this as the 2 points, okay, following the rule. You get these 2 points, you get this point here, 2, 3, being the center. And then we know that the gradient of the line is, using our formula and the fact that we have a point that where a point, so we have 1 over 3, and then so the gradient of the perpendicular to AB is 3, because remember we said that for a line, for these lines to be perpendicular to one another, if this is line L1, L2, then we said that the gradient, of L2 multiplied by the gradient of L1 is going to equate to -1, if you remember that. Okay, and so the equation of the perpendicular line, so you have the 2 and the 3, which is the point here, 2, 3, which is the center of the line where the line crosses, and you also have the fact that you have M which is the gradient, and so you can find the equation of the perpendicular line. So it's bringing, as you can see, things from C1 together. And the same thing here, you have some information and it's asking you to utilize that in order to figure out the answer. And this is all straightforward, nothing too difficult or trivial here, stuff that you've done before, and all you're doing is simply using the information you've been provided with the numbers that you have, and you're finding the answer. Very simple, very straightforward. This one is a little bit more lengthy in its working out, but again, following the same principles, nothing different. The perpendicular form of the circle, of the center of a circle, is a chord. The perpendicular from the center of a circle to a chord bisects the chord. Okay, so here you can see you have the center of the circle, you have a perpendicular from the center of the circle, okay, and it bisects the chord. This is the chord. Okay, a line that is perpendicular to a given line and bisects it is a perpendicular bisector. So the perpendicular bisector, you see it's perpendicular, it represents this green line here, but it's blue here. It's a right angle, this one's a right angle, and this is the chord, okay, or the line AB. And so now you can start to see some of the geometry come to play. So the lines A, B, and C, they are chords of a circle. The line y equals 3x minus 11 is the perpendicular bisector of AB. The line y equals minus x minus 1 is the perpendicular bisector of CD. Find the coordinates of the center of the circle. So you have the equation, the line, okay, already given to you, which is the perpendicular bisector of AB, and you have the perpendicular bisector of CD. So by using simultaneous equations, right, we can see that we have x is equal to 510, and then we have y is equal to minus 710. So the center of the circle is as follows. And again, this is just coming from these points intercepting at this line, and both these perpendicular bisectors originate from the center. Okay, just using your common sense to bring the pieces together. Some exercises for you to do. 4.2, you can find the distance d between x1, y1, x2, y2 by using this formula. And the distance, so the formula is d equals, which represents the distance, the square root of, and we have x2 minus x1 squared plus y2 minus y1 squared. Whereby we have this triangle here, graph, I didn't mean triangle, I meant line, and then d, which is the distance from here to here, here to here, and then again at this point you should already know that that's y2, so this is x, this is y, and this is x1, this is y1. Okay, so you need to find the distance between 2, 3 and 5, 7. So let's just do that example A. So we have 2, 3 and we have 5, 7. So we can just highlight the following. This is x1, y1, this is x2, this is y2. So let's plug them in. 5 minus 2 squared plus 7 minus 3 squared, square rooted. What do we do first? 5 minus 2, everything in the brackets, 3 squared plus 4 squared. Then we square them, so we have 9 plus 16 square root. Let's do it in the brackets, 25, which gives us 5. Okay, simple, very simple. Same thing with B, we're literally just plugging in the numbers. Okay, same thing with C again. You just have square roots, so you're playing around with the squaring and the square roots, so be very careful. And again, you can see that you're asked a question that incorporates the diameter of a circle with the points. Find the radius of the circle. So you find the radius, okay, so you find the diameter, the distance, okay. So imagine if the distance are the 2 points of a circle. So if I draw a really bad circle, no, it's okay, it's not too bad for a circle, it's not entirely symmetrical, anyway, and then obviously the radius will be half of that. So if that's the center, then that's going to be the radius. Okay, example 9. So again, you can see these examples are starting to crop up. You have this 90 degree here, so that means that there's going to be maybe a perpendicular bisector going through a chord. Okay, yep, it's 90 degrees. Okay, and so very simple. Let me just clear this. The angle in a semicircle is a right angle. So as you can see, this is another circle theorem. Any line or lines that are joined to the diameter is going to give you a right angle. Okay, anything, so any line, so if you do that, right angle. That's the theorem, that any two lines that meet at an angle will form a right angle. See that? Okay. The angle in a semicircle is a right angle. You can see that there. And so it utilizes this. And then 4.3 says, you can write the equation of a circle in the form as follows, where AB is the center and R is the radius. Okay, so we have that minus A squared plus Y minus B squared equals RC. AB is center, R radius. Write down the equation of the circle, 5, 7 and radius 4. So really it would be very simple. I mean, it's already given you 5, okay, so x minus 5 squared plus y minus 7 squared equals 4 squared. We have 16 here. Okay, that's as simple as it is. Let's draw it out a bit more neatly. 7 squared and 16, and this is the equation of the circle. So as you can see, just very simple, just adding. And I like to use the word simple because I hope that it gets into your psyche and you start to appreciate that it is simple. Breaking down psychologically the barriers that you might construct in your mind, okay, when you see these new sort of problems or these new areas of mathematics, and that might throw you off guard. Very simple, it's all psychological. Again, write down the coordinates of the center of the radius of these circles. Well, let's look at it. 3 minus 1, 4. So the radius is 4, and you have x, which is represented by 3, and y, which is represented by minus 1. And again, just refer back to the equation. Sorry, I should say the minus 3, sorry, and and 1. Okay, refer back to the equation. Okay, there we go. And for B, the same thing. If we look at it, we have 5, 2 as x, 3 as y, and then the square root of 32. Well, if we square root 32, what are we going to get? We're going to get square root of 16, square root of 2, and that's going to be 4, and that's obviously going to be the square root of 2, so we get 4 the square root of 2, as is done here in the center, as is proved earlier on. show the circle passes through this point, 5 minus 1. So for us to do this, all we have to do is substitute x equals 5 and y equals minus 8 into the equation of the circle. So we have x there and we have y there, we have 20, okay, and so we can see that the radius, okay, is equal to 20. So essentially what this is saying is that if you have a circle and the diameter is 20, you could say coordinates in some unit length, okay, if you add this point 5 and minus 8, so 5 and minus 8, okay, let's say it's that one there. If you put those coordinates into the equation of the circle and you have a number which is less than 20, or 20 for that matter, then the circle passes through that point, okay. If we were to get in this particular equation, like for example 400, just a stupid example to make the point, then that point, so let's say there's a point x and y that gives us 400, okay, then the circle would not have crossed that point xy in this particular case, whatever xy is. And again, you can find the equation of the circle using these 2 points. So some more examples for you to do in your own good time. The angle between the tangent and the radius is 90 degrees. So if we have a circle, so I'll draw a better circle. I hope that's an improvement. And then we have, that is meant to touch, okay, please ignore this line here. Let me draw it from another perspective, okay. Then when that tangent, imagine this is the center, please do use your imagination to imagine that this is the center. I'll put center just to avoid any bad drawing, any criticism for any bad drawing. This is going to make a right angle, 90 degrees. And remember we said the tangent touches the circle. It's like when we had the curve, remember, like if we had our x squared, y equals x squared, y, and then we had x, the tangent touches it at a point, okay. It's very similar to what we have here. And a tangent meets a circle at one point only, okay, so just 1 point only. And then using that, you can figure out this. Write down the equation of these circles, 3, 2, and 4, okay, and you'll go on to use this information to facilitate some other questions. Find example 15, find where the circle meets the x-axis, okay. So again, you just take the equation of the circle, and you know that when the x-axis meets, y is equal to 0, and so you're rearranging and you find x, okay. Example 16, 17, all very simple. And here you have exercises, mixed exercises, which symbolizes the end of the chapter. Summary of key points. So once more, you can see it's just a simple case of, here is an equation, sorry, here is the formula, here are some numerical values, plug them in, and from time to time you might be asked, well, here is another unknown, okay, which is not the conventional unknown in this particular equation, in this particular formula, find the unknown. For example, the distance d between these two coordinates using the formula is as follows. Sometimes you might be asked, well, don't find d, what's x1? Okay, so just some rearranging, alright, nothing too difficult, nothing too tasking. And again, just some points mentioned here, okay, some rules that are useful properties for when you're answering questions. It's good to have this in your utility belt of skills, because then you can use them at your own convenience to figure out the answers. So that was chapter 4. Thank you very much for listening, and hope to see you for our next video. Take care and goodbye.